So today we're going to start Unit 6. It's all about graphing linear inequalities. So we're going to go back to some of the basics, some of the stuff you learned in grade 10, and we're going to add to it. So in grade 10, grade 9 maybe, you learned how to graph lines, maybe even earlier than that. So what we're going to do is we're going to use your ability to graph lines, linear equations, and we are going to graph linear inequalities. So when you graph an inequality, you're going to shade an area in which it falls into. So the first step of this is to actually be able to graph lines. So we're going to do a review. So in order to graph a line, you can either use one of two methods, the x and y intercept method, or the method in which you're doing the slope-intercept form. You take the slope and the y-intercept and you graph. So to solve for an x-intercept, you set y to 0. X-intercept, we set y to 0 and solve. And to solve for a y-intercept, you set x to 0 and solve for y. So let's do this in our example here. So 2x plus 3y equals 6. So I'm going to do 2x plus 3y, but I'm going to put a 0 in here, is equal to 6. So in doing that, I get 2x is equal to 6. To get x alone, we divide by 2, so we get x equals 3. So when y is 0, x equals 3, so that point is 3, 0. Right? So for the y-intercept, you set x to 0. So this would look like 2 times 0 plus 3y is equal to 6. So 2 times 0 is 0 plus 3y equals 6. And then we will divide by 3 to get y is equal to 2. So that point is when x is 0, y is 2. So our point is 0, 2. Notice with x and y intercepts, I pick out points. Okay? You only need 2 points to draw a straight line. So we'll take these 2 points and we'll put them on a graph. So our first point is 3, 0. So x's are horizontally and y's are vertically. So 3, 0, that's right here. And then our other point is 0, 2. So 0x, positive 2 what? X right here. So we get 2 points. To get a straight line, we take a line and we draw both ways. So from here out this way, we go straight. Notice there's arrows at the end of my lines. I do it the opposite way, and that gives me an actual line. Beautiful. So I could draw a line using the x and y intercepts, set y to 0, solve for the x, set x to 0, solve for the y, use those 2 points to graph. Okay? So that's one way. The second way we can do it, feel free to stop if I'm going too fast, right? Stop, pause the video, draw it out for yourself, make sure you're good. The second way to do this is the slope and y-intercept way, or moving it so that it says y is equal to mx plus b. You guys probably remember y equals mx plus b from Mr. Thal's class. So m being the, you're right, the slope, and b being the y-intercept. Okay? So knowing the y-intercept, that's when x is 0. So it's 0, some number. That number is b. So using the same question, we got 2x plus 3y equals 6. How can I get it so it looks like y equals? The first thing we do is we subtract the 2x. Now, notice in this equation it says mx plus b. So anything with the x goes first, and then just the number at the second. So we get 3y is equal to negative 2x plus 6. We're going to divide by 3 to get y alone. When you divide by 3, each term gets divided by 3. Some people will put divide by 3 over everything and then forget they'll only do the slope 2/3 and then they'll put plus 6. But it's not. It's 2/3 x plus 2. So when we finish here, when we finish dividing by 3, we end up with y is equal to negative 2/3 x plus 2. What does that give us? Our slope of negative 2/3. So negative meaning it's going downwards. And 2, which is our b, which is our y-intercept, 0, 2. So how do we graph this? Well, we put our y-intercept down. That's our first point. 0, 2 is a positive 2. So 0, 2, that's right there. Now, your slope says negative 2/3. What does that mean? Well, remember, slope is rise over run. Right? Your slope means rise over run. So from this point, we're going to rise a negative 2. 1, 2, so we're right here. And we're going to run 3, positive 3. 1, 2, 3 gives me a point here. In this case, it gives us the x-intercept. You're not always going to end up with the x-intercept, but in this case, we did. 2 points, then you can graph the lines, right? From here to here, out, and from here to here down. Notice there's an arrow at the end of my lines, which insinuates that it goes on and on forever. So that's graphing lines 101, what you've learned before. Now we're going to move into inequalities, right? So graphing inequalities. So as we move forward, I want to make note. Look here, we do not have an equal sign. We now have an inequality. This is why it's called graphing linear inequalities, not graphing lines. Okay, so there's your inequality. If it has less than or equal to or greater than or equal to, sorry, this line thing here, that extra line means equal to, right? So less than or equal to or greater than or equal to, we're going to draw that as a solid linear line. But if there's no equal to line here, like in these cases right here, the line we draw is going to be dotted, okay? There's a two-process part to this thing. Okay? You graph the line, just like we just did. We're going to graph a couple lines, either x and y intercepts, or find the y equals mx plus b, and graph that, whatever you like best. Notice, when we're just graphing the line, we don't really think about the inequality. We just, if there's an equal to, there's an equal to right here, then we draw a solid line. If there's no equal to, then we draw our dotted line. So, let's graph. I took the question, which said 4x plus 2y is less than or equal to 8. And I just wrote it as an actual equation. 4x plus 2y is equal to 8. The first way I'm going to do is I'm going to do the slope-intercept form. Okay, so I'm going to solve for y. So I'll subtract 4x, and I'll get 2y is equal to negative 4x plus 8. And then to get y alone, I divide by 2. So I get y is equal to negative 1/2. Sorry, let's go back and do my math proper. 4 divided by 2 is negative 2x plus 4. What kind of information is this giving us? Gives us our slope is negative 2, which really is negative 2 over 1. So I'll rise a negative 2 and I'll run a 1. And my y-intercept is plus 4. So that's when x is 0, y is 4. Okay? So let's take this equation and go graph it. Am I going to draw a solid line or a dotted line? In this case, because it says equals to, I'm going to draw a solid line, okay? When we look at this question, our y-intercept was 0, 2. Now let's go back just so I'm sure. Our y-intercept was 0, 4, and our slope was negative 2 over 1. Okay, so let's graph our y-intercept, 0, 4, 0, 4 up, 1, 2, 3, 4. It's right here. Our slope is negative 2 over 1, down 2 over 1. That gives me my second point. Notice it's not necessarily the x-intercept, and I can draw my line through it. It's an equal to, so I'm drawing a solid line. Okay. And now we actually have to deal with the inequality. The fun part, the coloring. So you can take out your highlighter, your pencil crayon. We have to make it work. Okay, so we're either coloring one side or the other. So I'm either coloring below or above. The original equation stated 4x plus 2y is less than or equal to 8. We just pick a point on one side of the line. So I like to pick 0, 0 if 0, 0 is not on the line. Why? Because 4 times 0 is 0, and it makes math really easy. So this is 0, 0, so 0 in for x, and 0 in for y, less than or equal to 8. 4 times 0 is 0, 2 times 0 is 0, 0 plus 0 less than or equal to 8. Yes. Okay, if the answer is yes, you color on the side of the dot. If the answer is no, you color on the other side of the line. Okay, so you just pull out your highlighter, your beautiful crayons, and you color away. This is the enjoyable part of today. Okay, so we're coloring all of this. Okay, you can color much nicer than me if you want, but it works out to be anything. So any point I pick on this side over here, so if I picked 1, 0, and I put it in there, 4 times 1 plus 2 times 0 will still give me 4, which 4 is less than or equal to 8. So it still falls in all this colored spot. Okay? Let's look at another question. Graph this following equation. So inequality. Now if we look at this, it says 2x minus 3y is greater than 12. Okay? Notice there's no equal to, so what kind of line am I drawing? Yeah, you're right. You're going to draw a dotted line because there's no equal to. So dotted line we are drawing. Now we just have to decide, are we going to do an x and y intercept, or are we doing a y equals mx plus b kind of thing? Whichever one's your favorite. If you do the same one over and over again, that's fine. I'm going to do the opposite. Last time we did the y equals mx plus b. This time, let's do the x and y intercepts. So x-intercept, we set y to 0. So I get 2x minus 3 times 0 is equal to 12. Gives me 2x equals 12 divided by 2x equals 6. That gives me a point of 6, 0. Then I've got to do the y-intercept. Y-intercept is when we set x equals 0. So 2 times 0 minus 3y equals 12. Notice I'm putting the equal to solve for the points. This is the actual line. Minus 3y equals 12. Divide by negative 3, y is equal to negative 4. This means your point is 0, negative 4. Then you put the two dots on your graph here. 6, 0. 1, 2, 3, 4, 5, 6, and 0 in height, and 0, negative 4, 0, and then down 1, 2, 3, 4, right here. We need a dotted line because it's not equal to. So just grab your line, make sure it's dotted. Sorry, having issues here. And you just draw your line through here, dotted line, arrows back and forth. Okay, arrow saying it continues on forever. So that's drawing the line. Now we have to graph the inequality. So going back, our inequality is here. This 2x minus 3y is less than 12. Okay? So 2x minus 3y is less than 12. Is that what it says? I always check because I always write things. So greater than 12. I do that all the time. So greater than 12. We pick a point that's not on the line. I like 0, 0. It's not on the line. If it is, you actually just have to pick another point. Like 1, 2, 3, 4, 5. Negative 5 comma 0 is another point that's not on the line. Anything actually works, but whenever there's a 0, 0, I always do that one. But if it's on the line, you cannot pick that one. So plugging in 0, 0, because it's not on the line, 2x. So 2 times 0 minus 3 times 0, that's greater than 12. In this case, is 0 greater than 12? No. So what does that really mean? We have to color on the opposite side, because the opposite side is actually true. So you could pick a point way out here, like any of these points way out here. So I am drawing lines now. Any of these points way out here, and it would work. Okay, you could check it out. And then you just color that side of the line. Okay, color nicely, don't scribble. Okay, well, you can scribble if you want. Okay, last question. 7x minus 4y is greater than or equal to negative 28. Y equals mx plus b, or slope intercept, or x and y intercepts. It's up to you. When I look at this, I'm going to subtract 7x and then I'm going to divide by 4. So I'm going to get a fraction for my slope, but 28 divides evenly by 4. So when I'm actually putting on my y-intercept, it's going to be nice. I like to move it to y equals mx plus b, so that's what I'm going to do. I'm going to subtract 7x. I'm going to get negative 4y is equal to, we're just drawing the line right now, so we can put equal to. Negative 4y is equal to negative 7x minus 28. Divide by negative 4 on each term, so we don't forget. We get y is equal to, negative and a negative makes a positive, 7 fourths x, then negative 28 divided by 4, 24 divided by 4 is 6, so this should be 7. So negative and a negative makes a positive, so a plus 7. What does that give us? It gives us a y-intercept of 0,7, and it gives us a slope, a rise over run of 7 over 4. Okay, so let's graph this. 0,7 is right here, 0, up 7, 1, 2, 3, 4, 5, 6, 7, 5. Okay, now my slope is 7 fourths, so I can go up 7. 1, 2, 3, oh, I'm running out of graph. Hate that. You could draw extra lines if you want, but you can also go backwards with your slope, right? So instead of going up 7 and over 4, we can go down 7 and back 4, right? So going down 7, 1, 2, 3, 4, 5, 6, 7, and back 4, 1, 2, 3, 4. That's my other point right there, okay? And I can check, because from this point I can go up 7, 1, 2, 3, 4, 5, 6, 7, and over 4, and I get the possible slope that I'm supposed to. Now, do I draw a dotted line or a solid line? Take a peek. It's an equal to, right? Greater than or equal to, so we draw a dotted line. Here we go. No. Equal to means solid line. My goodness. Draw up like that. Doo-ba-doo. And down like that. Hopefully you're using a ruler. Heads up, use a ruler, please. And now we just have to decide what side of the inequality are we covering. Notice my favorite point is open. It's not always open. But if it is, 0 and 0 is nice. So plugging it in, I'm just going back to the original question. You can do it right on the bottom. I'm not scrolling down. I'm being lazy right now. I'm going to plug 0 in for x, 0 in for y, and it's greater than or equal to negative 28. Is 0 greater than or equal to negative 28? Yes, it is. So that means we color on the side of 0, 0. And we do that right here. Color nicely all the way down. Even this little bit down here too. Okay, it's all. That is graphing inequalities in Math Foundations 20. I hope that was helpful. Here's your assignment. I forgot one thing to tell you guys. And your textbook does two things. It either shades or it does dots. Now, when it's shading, it means you're including all the numbers, all the little decimals, all the real numbers. So if you're going to shade, that's the real numbers. Okay, that's when you write that. X is an element of the reals, or Y is an element of the reals. Well, when you're thinking reals, you're doing all the decimals, all the numbers in between, everything. Now, not everything deals with real sets. Some of things deal with whole numbers. So instead of shading everything, where your graph is, they actually color every single dot. Okay? Like that. And it's dotted because they're whole numbers or integers. Okay? Whole numbers are positive 1, 2, 3, 4. They're counting numbers pretty much. Integers also deal with the negatives, negative 1, negative 2, and 0. Okay? So if they say that you're dealing with integers or whole numbers, they're basically your counting numbers. It's like you can't have half a person, so they don't color in or shade in half a person. They actually put those dots in. 1 person, 2 person, 3 person, 4 person. They actually make it dotted. Okay? So you'll see whole numbers, which is just a W, or integers, which is just an I, which means the dotted kind of form. Okay? Now, your assignment is on page 303. You're going to do question 4. And question 5. And question 7 and 8. Question 4, 5, 7, and 8, page 303. Question 4, 5, 7, and 8. And I do realize question 5 has you graph about 6 questions. Okay? It's okay, you can do it. Good luck and have a great weekend. Don't forget to hand in your review for Unit 5.